All right, we've seen the easy problems, right? Now it's time to make things exciting. 4 and 7 over 20 plus, let's say, 6 and 11/15. Now I know you're going to like this one. Yep, I can see it in your eyes. Now, these guys don't have a common denominator, but we can fix that, right?
Sure.
Okay, we got to work on our enthusiasm. I'm the only person who's excited here. So I'm just going to rewrite this. So 4 and 7/20. Maybe I should just have written the problem like this to begin with. All right, so I need to get common denominators. If you are not sure about what the common denominator is, take these guys off to the side. Okay, just pretend that you don't even have denominators, because denominators don't really matter here when trying to get the common denominator. 20 and 15 have what factor in common? What goes into both of them? 5 goes into both of them. So I could write this as 5 times 4, and this is 5 times 3. Do you all agree? So remember what we did last time. We circle these guys because these are already in common. Yes? And we fixed this by saying I need to multiply this one by 3, and I need to multiply this one times 4. Remember how I just kind of crossed those guys over? That was the easy way to do that. If you can identify the common factor that they have, all that the fractions are missing is what the other guy has after that. So when I make this conversion, I multiply 20 times what factor? See, I multiplied it times the 3. What's 20 times 3? 60. Over here, you multiplied 15 times what? 4. What's 15 times 4? It should still be 60, right? Otherwise, we didn't really get the common denominator. So just with my little thought bubble scratch work over here, this helps me out. Because I multiplied 20 times 3, so multiply the numerator times 3, and that gives me 21. 15 got multiplied times what? 4, so this is 4 over 4. So I end up with 44 over 60. Do y'all agree? All right, so how much do I have in terms of the fractional part? This gives me 65 over 60. And what about for the whole number part?
10.
It gives me 10. Is this answer good enough? Why is this answer not good enough? It's not in lowest terms, and this guy isn't even a mixed number. Did you see that? In order to be a mixed number, this has to be a whole number, right? Which it is. This has to be a proper fraction, but 65 over 60 isn't, is it? Now, you've dealt with stuff like this, and this is where you kind of carry the 1. Do you remember that? Carry the 1. You don't? All right. Let me show you how you carry the 1. If I have 17 plus 15, what do? 7 plus 5 is 12, but can you fit the 12 in right here in that single digit? No, you'd put the 2, and then the extra 10 that you have picked up from that gets carried over to the 10s, right? Same thing here. I need 60 pieces to make a whole unit, right? I got 65. Oh, so that means I have enough to make another whole unit, right? Do y'all agree? And if you don't, think about this. 65 over 60. How many times does 60 go into 65? There's another whole piece with how many left over? Now you've got 5 extra pieces. Do y'all agree? So my 10 becomes what? My 10 becomes 11, and the 65 over 60 is going to reduce back to the 5 over 60, right? Because I had enough pieces to make another whole unit. And now I've got 5 left over. Now is this my final answer?
No.
No. Why is this not my final answer? I can reduce the 5 over 60. What's their common factor? Common factor is 5, so I still have 11. And if I reduce 5 over 60, I get what? 1/12. Yeah, that's pretty sweet. What do you guys think? Tim, you disagree? How did what part? Do you agree with the 65 over 60? Okay, well, with the 65 over 60, this is what happened. If I look at 65 over 60, this is a mixed number. It's an improper fraction, right? So I have enough pieces to make one whole unit, and I'm going to have 5 left over, right? So what do I do with this one? Well, it's the same thing that I did with this one. I have to carry it over to the 10. So I have enough pieces to make an extra whole unit to give me the 11. But then I have 5 left over, so 5 over 60. So you had enough extra pieces when you combine the extra pieces from one and the extra pieces from another, and you had enough to make another whole piece. It's like whenever you're making biscuits. Have you ever made biscuits? Like you're sitting there in the kitchen with your meemaw, and she's got the round cutter, she's making the round biscuits, you know what I'm talking about? Okay? And then what do you do with all this? You can't make round biscuits without having some extra pieces left over, right? What do you do with all those extra pieces? You mash them together and you re-roll it so you can make more biscuits, right? You take the scraps. These are the scraps. And I had enough scraps to make another whole biscuit, and then one, well, I may have to throw that away, right? Or it could be like my meemaw, she just makes a weird shaped one she puts in the corner, and that's for me. But of course I can't eat those biscuits anymore because of the flour, but oh man, imagine a hot, fresh biscuit with some homemade strawberry preserves on it, or maybe some pear preserves, some marmalade, some butter, and I'm not talking about margarine, I'm talking about butter. And then on the side you've got some thick cut bacon. You've got eggs that have been made. You have eggs that have been made in the same skillet that you cooked the bacon, so you got some of the grease from that. You guys don't know what good cooking is. You're like, Mr. Craig, my biscuits come from a can. You know, can we gotta pop it open, and go pow pow, and I just put my biscuits out. They're already perfectly round, Mr. Craig. That's how I do my biscuits. Ain't need no meemaw. What's a meemaw? A meemaw is what we had before Facebook and Twitter. If you wanted to know what was going on, you asked your meemaw. Surprised you guys don't know that, but that's okay. You're still young. If I have 12 and a third minus, let's say, 5 and 4/7. I already lined it up in a column. I said, forget this. I'm tired of having to rewrite everything. Can you get a common denominator for those fraction pieces? What's the common denominator for 3 and 7? It's 21, right? Well, what factor did I multiply the 3 times to get 21? Multiply times 7. So we have 7 over 21. What about this guy? Times 3, so I have 12 over 21. What? I'm going to have trouble here, right? Remember when you're doing subtraction, we can't subtract a large number from a smaller number, so we have to borrow? Remember that whole thing? I need to borrow. Again, this is how I do my fractions. If I look at my 12. I can see my 12 as being 11 plus 1, right? Now what I want to do with this 1 is I'm going to add this 1 to the 7 over 21, because I can't do 7 minus 12. So I'm going to borrow from this guy. How can I rewrite this 1? This 1 is what over 21? Nope. This 1 is 21 over 21, right? This is a whole unit, so that's 21 out of 21 pieces, yes? So when I borrow that 1, how many pieces am I borrowing? I'm borrowing 21 out of 21 pieces, right? So that's going to make all of this equal to what? It's going to make that 28 out of 21. Maybe an easier way of doing this is that when I need to make this guy bigger by borrowing, take this denominator and add it to the numerator. What's 21 plus 7? 28. But what I was trying to show you here is where would that 28 come from? It comes by taking one of these off of the 12. So when I do my subtraction now, what's 28 minus 12? That's 16 over 21. But do I have 12 minus 5 anymore? No, because I had to borrow 1 from the 12 whole units. So that's 11 minus 5, which gives me 6. Is this guy in lowest terms? I mean, you can't do anything with 16 and 21, can you? So these guys are going to stay just the way they are. So when I had the fractions here, I couldn't do the 7 minus 12, so I had to borrow. And where do I borrow? From the whole pieces. So I take 1 off of this, which is going to add back into this. But remember what you're adding back into it. You're adding 21 out of 21 pieces. So that's why I said you could just take the denominator, add it to the numerator, you get 28 over 21. Let's do another one just to make sure that you guys followed what I just did here. If I have 5 and 5 and 2/15 minus 2 and 7/10. In order for me to do the subtraction, I need to convert to common denominators. What's the common denominator for 15 and 10? It's going to be 30. I think the more of these you do, the easier you'll be able to see what the common denominator is. How do I go from a 15 to a 30? I multiply times what? By 2 over 2. So that gives me 4 over 30. And what did you multiply the 10 times? Times 3. All right. Can I do the 4 minus 21? No, so I'm going to borrow. Remember how I borrowed? So this is going to turn the 5 into what? Into a 4, and it's going to turn this guy into what? It's going to turn this, remember how I just add the denominator back in? Yeah. So this is now going to become 34 over 30. How did it go from a 4 to a 34? When I took the 1 off of this, that meant I was taking 30 out of 30. So 4 out of 30 and 30 out of 30 gives me 34. So now when I do this, what do I have for the fraction part? 13/30ths, and what about for the whole number? 2. Yes, Dennis?
But you only do this when that doesn't work, right?
I'm only going to do this borrowing when I can't, with the fraction pieces, I can't subtract that. Okay? So it's just like the subtraction that you would do before when you line things up in columns. If you can't subtract that, then you're going to have to borrow from the next number. You borrow a 10 or you borrow 100 or whatever it happened to be. In this case, I'm borrowing a whole piece, a whole unit, which gives me an extra 30 pieces, which is why it goes from 4 to 34. And that's why in the last problem it went from 21, or it went from 7 to 28, because I added it back in 21 pieces, because I had to borrow from the 12.